Hi, I am Mali, and welcome to the channel. I have lots of AI-generated images where the faces are distorted. Fixing them via manual inpainting is a tedious process. Using ClipSeg image segmentation, I can edit all these facial elements in one go. Also, with these same tools, you can take a photorealistic image and give it a graphical face. Or add some facial realism to a graphical AI-generated image. All this can be done without manual inpainting. Let me show you my workflow and hacks on how to do this in ComfyUI. A shout out to the channel members for their continued support. There will be 4 workflows in this tutorial. The workflows in the beginning are basic, and they become a bit advanced toward the end. Some custom nodes are required for the workflows. I will leave the GitHub page of Dr. Data in the description. Please thank him for making the ComfyUI manager and the quality of life nodes. Without his nodes, none of this would have been possible. Both the Impact and Inspire packs are required. Then install ClipSeg. This node is crucial for the last workflow. If you are loading the JSON file, do not install missing nodes. The Comfy Manager picks up another node, which will install unnecessary things not required for this tutorial. Ensure that you manually install this node. The Was Node Suit, Python GOS, and the Ultimate SD Upscale custom nodes are also required for the tutorial. To download the Ultralytics models, go to Install Models from the Comfy Manager. Search for Ultralytics. For the tutorial, I will be using these 2 models. One is for bounding boxes, and the other is for segmentation. I will use the SDXL base checkpoint and the refiner for the first workflow. These are the hugging face models. With this basic workflow, around 80% of your low-resolution photo faces can be fixed. The remaining 20% would be images that can only be partially fixed by a single pass-through. To check the robustness of the workflow, I will show you some worst-case scenarios and how the workflow can be tuned to make it work. 2 checkpoints, one for the base and the other for the refiner. A VAE loader for the base. Use the SDXL clip text encode nodes for the prompts. This node is from the Impact pack. Search and add to Detailer Pipe SDXL. This is a very useful node. What it does is that it creates a pipeline carrying information like the conditioning, VAE, models, etc., and reduces the clutter. So, if you add multiple nodes that require this information, you will have to connect these inputs again for each added node. This becomes messy with long workflows. With this node, we can avoid all that. The only difference between the SDXL and the normal version is the refiner inputs in the node. When you drag out the B-Box detector, it doesn't show up the Ultralytics node. Just search and add that manually. Anything in this suite with a provider means it provides some information, such as the different YOLO and segmentation models. Provider nodes are the source and do not require any input connections. The Ultralytics have bounding boxes and segmentation detector outputs. When connecting B-Box, ensure the model is a bounding boxes model only. Similarly, choose a segmentation model for connection to a seg-m input. B-Box detects the subject as a rectangle. In comparison, the segmentation model uses a silhouette as a mask. Segmentation combined with B-Box is more accurate, and I would be using a combination of both wherever possible. I will use the YOLO 8S face model for B-Box, and the YOLO 8N Seg2 model for the segmentation. For the silhouette extraction, the Impact pack uses a more sophisticated segment anything model instead of a segmentation model. The SAM loader model will be downloaded automatically. Search and add the Face Detailer Pipe node. Connect it with the Detailer Pipe and the Load Image node. The guide size value is used only when the detected mask size is smaller than it. If the mask size is larger than this value, it will just upscale it to the maximum size and then add details. The guide size 4 determines if the guide size value is based on the B-box detected area or the crop area. The crop area is determined by the B-box crop factor. The noise mask, when enabled, will add noise only to the mask area. When off, it will go beyond the mask area to add noise. However, it will limit itself to the area defined as per the crop factor. The force in paint will force regeneration even if the mask size is smaller than guide size. When it does that, the upscale factor is fixed at 1. B-box threshold is the confidence level of the detection. At lower values, smaller subjects will be selected. A higher value ensures only bigger subjects are selected. The Segment Anything model has different methods of detection. The detection hint determines which point should be included when performing segmentation. For example, center 1 means 1 point in the center of the mask. Vertical 2 means 2 points on the center vertical line would be included. Diamond 4 specifies 4 points in a diamond shape around the center point. To be honest, I did not bother experimenting with this option. The center one is what I will be using throughout the tutorial. Always add image preview nodes to the cropped, refined, enhanced alpha and mask outputs. The previews will help you fine-tune the settings. Let's choose this image and hit the Q prompt. At a 0.5 B-box threshold value, it has detected 5 faces. The detection system has a limitation. It can only detect above a threshold, which means if you want it to detect the smallest face only, it cannot do that. It will select all faces above that small value threshold. However, you can make it only select the main face. Just increase the value. In this case, to 0.8. The B-box dilation will increase the mask area. The right ear of the subject is not entirely in the mask area. To apply the detailing effect to the ear as well, the dilation should be increased. The SAM dilation will increase the overall mask area. Whereas the SAM B-box expansion will expand the mask towards the boundaries of the bounding box. Feathering is how well the mask blends with the background. A higher value reduces the defined edges of the mask. The crop factor value plays a crucial role. The model needs enough surrounding area to understand the context and add details. The value here is a multiplier of the area surrounding the mask. Later, I will show you practical examples of when this value should be changed to get the desired results. With the default grid size and max size value, I am not getting the desired results. You can see the face is not properly restored. When I increase the resolutions to 1024, I do get decent results. This, however, may be taxing on some systems, depending on the source resolution. There is another solution. After some testing, I understood that adding some sort of a prompt helps. However, getting the exact prompt for each image I tested became difficult. So, I added the blip analyzer node, which works in this case. You can skip it if you want to do manual prompting. To connect the string with the conditioning, add a node called text to conditioning. Here are the results for comparison. The 768 with the prompt gives the best results for the performance. However, going further below does not output the desired results for this image. I am taking an entirely distorted image. The sole purpose is to test how robust the workflow can be. It could not restore it, and this is expected. Running it through a second pass with the same checkpoint would not make that much of a difference since the output is terrible. So, I am going to use a different checkpoint. Since the first checkpoint is SDXL, ensure the second one is also SDXL based. Selecting a non-SDXL checkpoint would give an error. The checkpoint you choose depends on various factors, and you can choose any SDXL checkpoint you are comfortable with. Here, add an Edit Detailer pipe node. This is useful for making changes along the way to the existing pipe flow. Connect the face detailer to this node. Duplicate it, and the image output from the first face detailer will connect to the second one. This is much better. I tested this specific image with random seeds, and 6 out of 10 images were usable. For this workflow, I will delete the second pass nodes I added previously, the blip nodes, and all the SDXL conditioning and refiner. I will use a simple SD 1.5 base checkpoint and pass it twice through 2 face detailer nodes. Replace the detailer pipe node with the non-SDXL version. Duplicate all the face detailer nodes and connect them for the second pass. There is a reason why the base SDXL is not used here. It just doesn't work. Fine-tuned checkpoints work better for intrinsic details. Depending on the desired output, the checkpoint is crucial here. A checkpoint trained for anime will not work in adding realistic details. I will show you some examples. Say I want to change the face to a more realistic look. For this, I am using the Juggernaut Reborn checkpoint. Unless the model gets something wrong, I prefer only to use the negative prompt and leave the positive empty. Let's try another example without changing any settings. I will show you one example of using a prompt. Using the Dream Shaper checkpoint, I will try and convert the face to an illustrative style. For the positive, I will just put illustration and vector art. This is a feminine look and is not consistent with the original image. I am only going to add the word male in the positive prompt. And it's fixed. One last example to show you why the second pass. Some checkpoints do cause some artifacts in the first pass, but they get corrected in the second. And some checkpoints, on the other hand, overdo the image in the second pass. For this workflow, delete the second pass face detailer nodes. Also, delete the Ultralytics provider nodes. The objective is to have different facial features auto-selected upon command and enhance or change them in one go. Except for the hair selection, everything else is pretty straightforward. To automate the hair selection process, you have to create a whole new set of nodes, but once done, it is very accurate. As shown earlier, I am adding the blip nodes for the positive conditioning. This works best and maintains consistency with accurate prompting. The media pipe face mesh detector is specifically designed for facial details. Bbox and segem are combined in this node and should be connected to the detailer pipe. All you have to do here is enable a specific facial detail. It then automatically creates a mask for it. Let's cue prompt first. Since the face was selected, it's masked the face. Let's change that to the left eye. Pretty cool, huh? You can add LoRa and a prompt which will affect only the mask area. Let's add an SDXL compatible LoRa to enhance the eyes. Also, adding light green eye to change the eye color. To select another facial detail, add an Edit Detailer pipe node. Connect the pipe from the face detailer output. Then, duplicate and connect the media pipe face mesh node. Duplicate the face detailer nodes and connect them with the Edit Detailer pipe. I will copy and paste the same prompt and change the eye color to blue. You can now repeat this process to automatically select each media pipe face mesh node element. I will be using clip segmentation to automate the hair selection process. Add the clip seg node. The clip seg can detect single word categories like person, face, hair, clothes, etc. First, we will generate the hair mask. For the tutorial, the blur value should be set at 1. A higher dilation factor would mean a bigger mask area. For the hair, this is based on image to image. Start with 4 and go up to 30, depending on your desired hair coverage. The threshold value determines the sharpness of the mask edges. A lower value spreads it more and gives it a fading gradient. At the same time, a higher value makes it more defined and sharp. Figures ranging from 0.35 to 0.5 seem to be the best. However, it depends on the image. Duplicate these 3 nodes and create a mask for the face. We want to avoid any denoising happening on the face. This node doesn't come up in the search. So right-click, Add Node, Impact Packed, and Operations. Here, select the Mask minus Mask node. We need to subtract the face mask from the hair mask. Connect the hair mask with the first input and the face mask with the second. The mask generated by the clip seg node is not binary. To convert it, add to binary mask node. When you increase the dilation for the hair mask, say, to a value of 40, you can see the mask expands outwards as well as inwards. We want it to expand only outwards, otherwise the face would be regenerated. This is where the mask subtraction is useful. To generate the hair, I will add the detailer for each debug pipe node. A higher value in the mask threshold will reduce the mask area, and a lower value will increase it. This is used to fine-tune the mask further. The mask has to be converted to segments. This node will then connect with the detailer debug input. The combined value should be set to true. I have already explained the crop factor before. To get the other details to this node, we need to create a basic pipe. Add a node called to basic pipe and connect all inputs. Drag it out till the second face detailer and add a node called from basic pipe version 2. Before we connect this node to the last detailer, we need to modify the prompts for the hair. So add an edit basic pipe node in between. Add clip text encode nodes and complete the pipeline. Let's try curly blonde hair in the positive prompt. Oops, don't forget to connect the clip inputs. Nice. Now let's try something else. How about straight purple hair? A couple of things here. This can be fixed by reducing the mask threshold binary value or increasing the mask dilation. If the hairs are short, you can increase the length slightly by increasing the mask size. Here, I will reduce the face mask dilation to 1 and the mask threshold to 30. You can really fine-tune the hairstyle by adjusting the mask. I am trying to make changes to both the eyes and the mouth. I want to show you some of the settings that affect the generation. When dealing with confined areas like eyes, lips, or eyebrows, the model sometimes does not have enough pixel data to understand the context. This causes artifacts in the output. And it can be corrected by expanding the cropping factor and giving more data to the model to work on. Have a look at this area. Increasing the B-box dilation to 50, the SAM dilation, and B-box expansion to 3, along with the crop factor to 4, fixed it. If changing the settings has a negligible effect, then keeping the same settings, try random seeds. Some distortions can be produced due to the hair overlapping the clothes. Reducing the mask is not a proper solution here. In such cases, a clothing mask has to be created and subtracted from the overall mask. Creating a clothing mask is the same as the hair mask. The text for the clip seg should be clothes. Duplicate the mask subtraction node. The clothes mask will connect to mask 2. The output from the first mask subtraction connects to mask 1. Adding clothes subtraction gives a better result. We can further streamline the process by using the switch node. The switch node setup will allow you to switch between all masks, only face and hair masks, and only hair mask. Rename the first binary node to all. Then, search and add the impact switch node. Connect the binary to input 1. And connect the switch and mask to segs nodes. Add another to binary node connecting with the first mask subtract. This will be the face and hair only. Duplicate it again and connect only the hair mask directly to this node. Rename it to hair only. Connect hair only to input 2, and the hair and face only to input 3. Rename the switch any node for reference. And that's it. Change the select value based on the image before hitting the Q prompt. For the upscaling, add the Ultimate SD Upscale node. Switch the mode type from linear to none to avoid adding further details during upscaling. This will be a basic image-to-image upscale only. I recommend 1.5x to max 2x at a time. Extend the basic pipe connection. Add another from basic pipe node and connect relevant inputs with the Ultimate SD Upscale. And that's about it. I hope the tutorial was helpful and you learned something new in Comfy. Until next time.